know about some of your backgrounds. Who have no experience with Python and other programming languages, and I have never ever coded before, please raise your hand. If you at least have some degree of coding experiences, and for those familiar with NumPy and Pandas, please raise your hand. All right, so for the other two students, you are just you have some coding experience, but you haven't used Python before or haven't used NumPy or Pandas before, right? So perfect. Let's get started. So since all of you have some experiences with with Python, and maybe I will just be really quick with the Python basics section and jumpstart with the NumPy and Pandas package part. And we will also cover a little bit of the data visualization using Matplotlib. That will be quite easy, and that will be covered at the last part of our workshop. So this is a very interactive interface using Google Colab, and you might have Python and both Jupyter Notebook on your laptop. And today we're using Google Colab for because I'm afraid that some of you may not have Python on your computer. So have all of you open that page, and can you run the first line of code checking the version of Python? If you are successful doing that, please raise your hand. Is there any problems with that? All right, perfect. Oh, we have some new students.
I'm not doing that. Do you know if there's like some other way to access the document?
Share the link on Zoom. All right, I will share the link on Zoom too. The link is also on Zoom, and make sure that you enter the link and make a copy of that document, of that Colab document, into your Google Drive, because you cannot directly edit that. So let me just continue with the contents. And by running the first line of code, you can see the Python version. And if you are successfully running this line of code, meaning that your Google Colab is working fine, and we can just continue to the next section. And for the students who have just come in, there's a link on both our Slack channel and our Zoom, and you can click the link and follow our tutorial, hands-on tutorial with me at the same time. Python is a really high-level programming language. So if you have not experienced with programming before, and do not be freaked out, because Python is really high-level, meaning that that's really similar to natural language, and it's some people say that it's almost the same as pseudocode. So maybe it is very understandable. And as for this chunk of code, it's just an implementation of the quicksort algorithm. It is fine that you do not understand this chunk of code, but after the today's workshop, you will be able to understand. And you can see that we entered array of numbers into this into this function. After implementing the quicksort function, the array is sorted. So this is just a simple implementation of a chunk of Python code, and just give you some give you a basic understanding of the Python language. So we can cover today. We will cover some of the basic Python concepts, including some data types, containers, and we will also cover some very common Python packages like NumPy and Pandas and Matplotlib. So as for the basic Python data types, and first of the data is the numbers. Can you see my screen, or I'm just gonna zoom in a little? All right, I will zoom in a little. So as for the numbers, integers and floats are the basic types of number on pandas. And for the mentors at present, if I'm not accurate enough, you can just speak up anytime so that I may be very precise with this workshop. So if you operate the first line of code, which assigns 3 to the variable x, you can see that when you print at, you can see 3, and type x is the type of our variable, and that is integer. So when you assign 3 to x, you can see that the type of x is an integer. And there are also some basic calculations, including addition, subtraction, multiplication, and exponentiation through the integer. And after we run this line of code, we can print these results. This is very straightforward, and this is very easy to understand. And there are also some other operations like x plus equals 1, meaning that adding 1 to x, and after we print x, and we have 4, and when we multiply x by 2, and by writing x multiply equal 2, we have 8. Because we have already changed the value of x through the first line of code, we assign 4. Before that, we assign 3 to x, but we then add 1 to x, so the x becomes 4. So when we are multiplying x by 2, and we get 8. So the variable x is constantly changing by assigning our values inside this variable. So here is one of the practice, and maybe one of the students may be able to answer the next chunk of code. The gentleman over here, can you answer what is the type of y here? Yeah, the type of y is float, and how can we and what are the results over here? Yeah. That's correct. And after that, what is the value of y?
It's still 2.
Yeah, because we haven't assigned any values like this into the y variable, so we are only printing the results of these values, but we are not assigning the value to y. So y is still 2.5. Let's just continue to the next part. Apart from numbers, we also have a Boolean variable which is either true or false. So for this type of code, we are assigning true to t and false to the variable f. And when we print the type of t, we get a class of Boolean variable. A Boolean variable can be either true or false. And like the logical operators in other languages, we can also conduct and, or, not, and exclusive or to the Boolean variables, and we can see what that is getting, what this line of code is getting. And when we assign true to t and false to f, when we print t and f, we get false, because they're just like the logical and, there's a true and a false. So with the and logic, we get false. And with the or logic, if there's a true in this type, in this two variables, we get a true. And not t, as for not t, because t is true, so the logical not, meaning the opposite of t, so we get a false. And the second and the last one is exclusive or. Exclusive or means that if you have one true or one false, we get a true, but we have both true. As for the or logic, we get true, but if we get the exclusive or, meaning one true and one false, if we have two true variables, then we get a false. So as for this time, the result of the last line of code will be true. And after the string, after the numbers and the Boolean variables, we will go to strings. That is very easy to understand too. As for the first line of code, we are assigning the string hello to the variable hello. This is a little bit confusing here because the first hello not in the quotes. These are this is a variable. You can also call that hello or hola or something like that, but we can assign the string hello to this variable. The variable name doesn't matter. And string can we can use both single quotes and double quotes for strings, and that will be the same. So but if you want to include a single quote in a string, maybe you can use a double quote as the outer part of the string, and then you can use a single quote inside that. So when we print hello, we get the string hello. We are printing the that like the value of the variable hello. If we change that into hola, and maybe after we print hola, we still get hello. And the length hello means the length of the string, which is 5. I will convert that into hello again. And there are a lot of operations that we can operate on the strings. And one of the operations is called string concatenation, meaning adding some of the strings together. In this case, we are adding the string hello and a space and the string world together. So we are adding, when we concatenate the string, we can get hello space world. So we can also format the string by using this. And maybe one student can guess what is the output of this of this line of code. Maybe the girl or maybe the lady on the first line. What's the output of this line of code? This one. Yeah, this is also hello world. You can format the string by putting parentheses right here and put the thing you want to get put into that inside the format. So maybe we can, so that the world will be into that be into that parenthesis, and we'll get a hello world. There are also other operations that we can do on the string. And as for this one, when we can capitalize the string and by only capitalizing the first letter, and we can also do the upper function, which is converting all of the cases into an uppercase. And when we adjust that by 7 spaces, we use the padding. We use padding to to adjust the string right by 7 spaces. And when we center that by 7 spaces, you can see that hello is centered here, and there are 7 spaces on both on the right and the left. And we can also replace some part of the string with another string. For example, we can replace L with ELL inside the parentheses, and after operating that, we get this string just replacing all the L's by ELLs. And also we can strip the string by eliminating the spaces on the right side and the left side of the string. So when we strip this string with spaces on both the right and the left side, we get just the string word without any spaces on both the right and the left side. So for now, we're familiar with some of the basic types of variables in Python, and we can just move on to the Python containers. Python includes several built-in container types like lists, dictionaries, sets, and tuples. We will continue with lists. Sorry, it's a little bit slow right here. All right. A list in Python is equivalent of an array, but is sizable and can contain elements of different types. You can also alternate some of the elements in a list. And for this code, we are assigning a list. You can see some numbers in a bracket when we are assigning this list to the variable called xs. And we can also get to one of the elements in the list by indexing the list. So there is a very important thing that the index starts from 0. So for 3 on the first position, the index is 0. So for 1, the index on the second position, the index will be 2. And for 2 on the third position, the index will be 2. So as for the list xs, we have index 0, 1, and 2. And when we print xs, the index of 2, we can get that 2 on the index 2. And when we print xs, the index -1, index -1 meaning the last element of the links of the list, which is also 2. And for this operation, we are assigning the string foo to the second index of the list xs. So after we do this, we print xs, we can see that this third element in the list becomes foo. And when we append another element into the list and we append bar to the list, we can see that there are 4 elements in the list xs. So we have learned indexing the lists and appending a string or a number to a list, and then we pop that, and the pop operation just removes the last element of the string, and then we get a string without the last element. And one of the very important operations that you can use with the list is called slicing the list. And slicing the list, meaning slicing the list by index. First, we create the list using the range function, and the range function is the built-in function that creates the list of integers. Maybe I will just paste that here. All right. Okay. So here we generate a list of integers of 0 to 4. And when we print and we assign this list to the variable called nums. So when we print nums, we get the list, and when we use this kind of operation to slice the list, and these numbers are the index of a list. So can anyone answer all of these questions without looking at that, without looking at the answer? Maybe the lady on the first row. And when we are slicing the list from the 2 to the 4th index, why do we got 2 and 3?
Because
yeah. Yes, thank you. Thank you very much. You're right. We're containing the left index, but we are excluding the right index. So as for this one, we're getting the index 2 and index 3 of the list. The index 2 means in the list is 2, and the index 3 of the list is 3. So we get a slice of 2, 3. And as for other operations, because of the time limit, I will not further illustrate on that, but I have just I have just explained what the operation is about by on the left side. So maybe if you have time, you can just look through and play with the code and also slice another list using these functions. And maybe I will just continue to the next part. And you can also loop over the elements of the list like this. And we have a list called animals. And when we loop through the list for animal and animals is the list that we have assigned before. And as for animal is for every element in the list animals. So for every animal in the list animals, we will print animals. So that will loop through this list and get cat, dog, and monkey. So there are, so this for loop is operated 3 times. And as for this one, we can also get the index of a list by the enumerate function. So the enumerate function gets both the index and the element. So when we loop through, when we operate these line of code, we loop through the list by looping through both the index and the elements. So after we print that, we get the first index is cat, the second index is dog, and the third is monkey. This is a formatting that we explained before, and when we format that, because the first element, the index of the first element is 0, but that may cause some confusion. So this time we're adding 1 to the index so that we get that the first element is cat, but actually the index of the cat is 0. It starts from 0 and end with 2 in this list. And in this list, we can also transform the type of data in the list into another. And for this one, we can operate and see what's happening. We are assigning a list to the nums, and we are also assigning an empty list to the variable squares. And for every number in the list nums, we are squaring that number and we are appending the square into the list of squares. So after we operate these line of code, we will get all the squares for the for the numbers in the first list. We can also make a simpler code by executing this line of code. It just does the same thing, but it uses less spaces. When you code, and you can use this kind of list comprehension techniques so that your code will be shorter. And list comprehensions can also contain conditions, meaning you can incorporate an if inside that a conditional condition. You can contain a condition inside the list comprehension. For example, for this, can anybody tell me what this line of code is doing? And this is a slightly different than the last one by adding an if the mode of x by 2 equals 0. What does that mean? Can anybody explain that to me? Maybe the girl on the third row. Yeah.
I think it's doing the same thing as the code before. Only taking the numbers of that are divisible by 2.
Yeah, we are only doing the even numbers. So we are only squaring the even numbers of 0, 2, and 4. Thank you very much. After the list, we will continue on to the dictionaries. Dictionaries is also a container, and it stores data by key value pairs, and is similar to map in Java and an object in JavaScript, if you have experiences with these 2 types of languages before. And as we can see that this is a dictionary, and the cat is the key and the cute is the value of the key, meaning the key can the key cannot there may be one and only one cat in this dictionary, meaning that there may not be duplicate keys are not allowed in dictionaries. So when we print dcat, we are getting the value of the key cat, which is cute. And we can also check if a dictionary has a given key by using cat in D. And this returns a Boolean variable of either true or false. And for this one, cat is indeed in D, so we get an output of true. We can also set an entry in a dictionary by adding a new key to that. And when we add dfish is equals wet, we are assigning the value wet to the key fish. So when we print dfish, we are getting the value of the key fish, which is wet. And we are, if we want to get one of the keys that is not actually present in the dictionary, we will get a key error, because there is no such keys as monkey in this dictionary. But if you use the get function, which is not the same as the last one, we can get when we use the function get, if monkey key is not actually in the dictionary, we will create a key called monkey and assign the not available value to the key. So when we use get, even if the key is not in the dictionary, we can create a key. And we can remove an element from a dictionary by using delete. And this is an operation of the code. Yeah. Because fish is no longer a key, we deleted the key fish from the dictionary, and this time we get not available. And as we can iterate through a list through the for loop, we can also iterate over the dictionary, keys in the dictionary using a for loop. Sorry, my computer lags a bit. And this is an example of looping through the keys and key value pairs in the dictionary, because the data in the dictionary are presented as key value pairs, but so that we have to use two variables in the for loop in order to get the key value pairs inside the dictionary. If if we only assign one variable like this, we will get an type error. We will get an error. And same as a list, we can also do some comprehensions in the dictionary, and they are similar to list comprehensions, but allow us to easily construct dictionaries. For example, we can construct dictionary using this line of dictionary comprehension, and this just saves spaces. And apart from dictionary, we also have dictionary and list. We also have two types of containers, which are sets and tuples. The set is an unordered collection of distinct elements. The elements in the sets are different from a list, must be distinct, and that is unordered, and a list is ordered. And then for this example, we create a set called animals, and that includes cat and dog. And we can check whether an element is inside a set by using the in expression, and that will return a Boolean variable. That will return a Boolean. And we can also add an element to a set, like adding a fish into the set animals. And when we print the length of animals, it will be through, because we add another element. Adding an element that is already in the set does nothing. And when we remove an element from the set, we can also do that by the remove function. We can also iterate through a set like this. It's just the same as dictionaries. And set comprehensions are similar as list comprehensions, and we can easily construct sets and use set comprehensions. That is quite the same with these data, these types. And apart from sets, we have tuples. A tuple is an immutable ordered list of values. Because we can change a value in the list, but for the tuple, we cannot change that. The tuple is immutable. For example, in this, we're constructing a dictionary with tuple keys. Tuple can be the keys of the dictionary, but lists cannot. So by this one, we are creating a dictionary with tuple keys in range 10, which means that the dictionary will be the key of the dictionary will be 0, 1, and the value will be 0, and in range 10, meaning that there will be from 0 to 9. So the D will be 0, 1, 0, 1, 2, 1, 2, 3, 2, and just like that, and goes to 9. And as we are creating another tuple 5, 6 called T, and we print the type of T, we get a class of tuple, and we will print the value of T, because T can be a key in the D dictionary, so we get a 5. And when we print the value of the key 1, 2, we get a 1. And when we are trying to change one of the values of the tuple, because tuples are immutable, so we get an error. We cannot change any of the elements in the tuple. After introducing all of the containers, including lists, dictionaries, sets, and tuples, we can move on a little bit to the function and classes, because these the content of this workshop can be covered in one semester, so that will be a super condensed one. But after getting a view and concept about how these kind of operations work, you will do better in the next machine learning workshops. And if you have any questions, just feel free to ask mentors. Yeah, sure. So as we can see that the lists cannot be key as a dictionary, but tuple can. So if you add a line of code here, we are seeing what's inside D, all right? So the D will be like this, and this is the key, and this is the value. So you can see that tuples can be a key of the dictionary, right? Anyone has any questions? Sorry, I'm going a little bit fast because this is really a condensed class. So we will move on to the function. The structure of function is like that. We will first define a function, and this is the name of the function, and we're defining a variable inside that function. And function must have return values, meaning that you have to, when you operate the function, the return values are the results, like the like what we are storing inside in the computer about the results of the function. So you have to return something. If you do not return something and you call that function, that won't work. We define a function called sin x, and if x is bigger than 0, we return positive. Smaller than 0, we return negative, and else we return 0. So when we call that function for x in this list, we call that function. So for every x in that list, we will operate that function, and we will print the return value of that function. So when we operate this line of code, we can see that the results of the function are over here. And we can often define functions to take optional keyword arguments like this. And we are formatting that into an uppercase. And in this case, we are formatting the name into this string. So this is a conditional function, and if and the default of loud is false. So when we this is called and when we operate these line of code, what will we get? Please, the lady on the second row. Can you answer when we execute hello Bob, what will we get? Mm-hmm.
And then it doesn't have like, it doesn't answer the balance, but that's like the-
Yeah, Bob Bob is equals to the name here. So so what will we get? If we did not assign a value of loud, the value of loud is default to false. So if we set the value of loud to true, then it will not ask you the default, it will be set to true. So for the Bob case, the value of loud will be false. So what will we get here? Yes. Yeah, it will get a hello Bob, but not in the uppercase, but in the lowercase. And if we have Fred here and we set the value of loud to true, we will get a hello Fred in all the uppercase. So here is the results. So this is a very simple execution of a function, and hope that you get a brief understanding of how function works. And also we have classes. Classes are a little complicated, more complicated than functions, because you can see that there are functions inside classes. I will try to make that clear to you. For every class, because Python is a object-oriented programming language, so nearly everything in Python is an object, and class is like an upper level thing of this objects, meaning some of the features, or there are some groups of projects that you can put that into a class. Maybe this chunk of code will give you a better view of the classes and objects. For example, we have a class called greeter, and inside that greeter class, and here we are creating a greeter class, and you can have a lot of objects inside that greeter class. For example, if we want to greet someone, we can greet a lot of people, and we can greet like Fred or George and any other things. And inside the class, we can there is also a constructor calling an init function, and for in this init function we assign some features to the objects of the grid, to the objects that belongs to the class. So in this for this one, we are assigning create the instance variable, and we assign the name to the feature name of every class. So in this time, if we initiate an instance in the class, and an instance is an object in the class, if we initiate an instance called Fred in the class, and the name is Fred, so we will assign Fred to the name feature of the object. And we are also defining some methods, calling methods of the objects. This is an init function of the object, and these are the method. And one of the method is called greet. And greet is a variable. It's a function, and this is a conditional one. If loud is true, we will print that in the uppercase, same as the last one. And if the loud is defaulted to false, we will print a lower level of that. So can anyone answer what are the outputs of these line of code? Maybe the gentleman on the third row.
The second line will do lowercase. And
Yeah.
the third line will do-
Yes, and there is another bonus question for you. What if we want to you tell me and I will type. If we want to define another function called farewell, saying bye, and what can we how to write that? Can you can you tell me?
Same thing, right?
Mm.
The first time you said the string color was the-
Yes. So we should also always have self as the first variable and in every function in a class. And here, we will not do the loud thing. We will just do the we'll say bye. And what if we want to what if we want to do the farewell method on the instant we caught Fred? And what line of code shall we write? Here. What is the code? Oh, right. That's quite straightforward. So we can see that we are creating like this. Yeah. So we got a by Fred. And if we create another instant called age, and we create another instance of that class reader, and we can say Alice. And we in this time we should if we want to conduct the farewell operation on the instance Alice, we have to do h.farewell, and we will get by Alice. So you can see that the trick of the class here is that if we create a series of objects that have the same features or share some kind of common features, we use class so that we won't have to write the code all over again and again, and this just boosts the efficiency of our codes. And you will come across a lot of classes, class and functions in the next workshop. So maybe you can just today's workshop is for you to just get familiar with the concept and how these kind of code work, and you can get used to the structure of that, so that when you come across a more complicated code, you may be able to read that. At least you know what kind of this code is how this code is structured and what these chunk of code is doing. Then we may move on to the NumPy. NumPy is a core library or package for scientific computing in Python, meaning doing math. If you're already familiar with MATLAB, you might find the tutorial here to start with. And there are a lot of documentations that I linked through this tutorial, and you can click to that tutorial or to that documentation. And documentations and Google are also your best friend. If you do not know which function mean or the method or the feature of one class, you can get to that function. You can get to that documentation and see how to write that code. Sometimes, well, we may forget about how to write a line of code, and we can get to Google or the documentation, and you will be all set. First, we import the NumPy library through to our environment, and here we can initialize some NumPy array. A NumPy array is a grid of values and all of the same type, and it's indexed by a tuple of non-negative integers. The number of dimensions is the rank of the array, and the shape of an array is a tuple of integers giving the size of the array along each dimension. And we can first initiate a NumPy array by this type of code. And here we create a rank 1 array to the and assign that value to the variable called A. And when we print the type of A, we can get that the type of A is a NumPy array, and the shape of array is rank 1 array with 3. And sorry. And when we can also index the array by using the bracket, and here we get the 0 index of the array is 1, and the first index is 2, and the index 2 is 3. And if we assign 5 to the first as to the 0 index of A, we are muting the array here, and we get an array 5, 2, 3. This is quite straightforward. And for this, we are creating a rank 2 array, meaning that you can think of that as a 2 by 3 matrix here. Does anyone haven't learned linear algebra before? All right, that it doesn't matter. It's just you can see that as a rank 2 array and also a matrix. So when we print the shape of the array is a 2 by 3 matrix, and this kind of indexing, we're getting each of the elements in the matrix. For example, 0, 0 is the 0 row, the row index 0 and the column index 0, so that we will get 1. And row index 0, column index 1, we will get 2. And row index 1, column index 0, we will get the first element on the second row, and which is 4. NumPy also provides many functions to create arrays. For example, in this time, we are creating a ranked 2 by 2 array filled with zeros, and by using np.zeros. And this one, we're getting an array full of 1. And this time, we're getting a constant array, 2 by 2 array, and filled by 7. And this time, we are creating an identity matrix here. And for this, we are creating a array filled with random values using np.random. This is all very straightforward and very useful when we are in the next 2 workshops. Yeah. And follow up to the array indexing, and NumPy offers several ways to index arrays. And for similar to Python lists, we can also slice the NumPy arrays by using indexes. And because arrays may be multi-dimensional, you must specify a slice for each dimension of the array. For example, here we are creating the following rank 2 array with the shape 3 by 4. Rank 2, you can understand that as the dimension, like this is a 2-dimensional array and with the shape 3 by 4. And for this one, we are slicing the array and we are just indexing in the array in each of the dimension. Like here for the first dimension, we are slicing the first 2 rows, and in the next one, we are slicing from the first to the second from the first to the second column. So here we have from the second to the third column, because the index is 1, 2, 3, and we're excluding 3, so the index will be 1 to 2, and so that will be the second to the third column. That's a little bit tricky, but we will get used to it. A slice of an array is a view into the same data, so modifying that slice of array will also modify the original array. If we assign the 77 to the to the 0, 0 position of B, and when we print that array, when we print the parent array, and that array, the position, the number on that position will also change. We can also mix integer indexing with slice indexing. However, doing that will yield an array of the lower rank than the original array. You can see that if we are creating a follow rank 2 array with the shape 3 by 4, and we're creating that here, and we are slicing that array with different methods. There are 3 separate methods, and you can see that the array we are getting is kind of the same, but the rank of that array will change following these different methods. If we are only using the integers, not using the slicing method, if we are mixing the integer indexing with slices, and we'll yield a array of the lower rank, and the rank of this is 0. But if we are using the slicing, not using integers mixing with slicing, we will get a 1-dimensional array. We can also make the same distinction when accessing the columns of an array. This is the row and these are the columns of the array, and you can see the operations right here. We will move on to the next part. These are basically the similar to the last to this one. So because of time constraints, I will not further illustrate this. Okay, and another useful trick with integer array indexing is selecting or mutating one element from each row of a matrix. And this is an example. First, we create a new array, which we will select the elements, and this is an array that we have created. And in this time, we are creating an array of indices, and this is an array of indices that we are creating. And for this line of code, we're selecting one element from each row using the indexes in B. So in this time, we are getting the first element on the first row, the third element on the second row, the first element on the third row, and also the second element on the fourth row. And here we get 1, 6, 7, 11. We can also mutate one element from each row using the indices in B, and by plussing that by 10. So can anyone answer what's the output of these code? What does this code mean? Maybe has anyone haven't answered before? Yeah, please.
So the 1 will turn into an 11.
Mm-hmm.
6 will turn into a 16. The 7 will turn into a 17. And the 11 will turn into 21.
Thank you, that's correct. So we will get a matrix with the numbers on the following indices plus by 10. There's also the Boolean array indexing, and it lets you pick out the arbitrary elements of an array. And frequently, this type of indexing is used to select the elements of an array that satisfies some condition. And here is a simple example. We are creating an array like this. And for this, we are finding the elements that are bigger than 2. And this returns a NumPy array of Boolean variables. So, and for the output of this one, we're getting whether each of these elements is bigger than 2. And this is a Boolean array. This is all very straightforward. And we can do all of that above using a single concise statement like this. So we're getting all the elements in A that is bigger than 2. This is a concise version. Sorry, my computer is lagging. And also about the data types. There are some as you run this type of code, and if you are not specifying the data types, then NumPy will choose the data type, it will guess that data type for you. So if you assign the array 1, 2 to X, and you can see that the NumPy just chooses the data type as integers. And if you have a decimal point over here and let NumPy choose the data type for you, and that will be a float. But if you set that data, you can also force a particular data type to ensure that the data type of all your data are the same. So this is also very useful in many of the database and the pandas operations by selecting by fixing one of the data types so that all your data types are consistent. There's also some of the simple math by on the NumPy array, and that is also very straightforward. And these are like just like matrix calculations, and we're adding if we assign the arrays to X and Y, and that will be the sum of X and Y. And these two line of code operate has the same meaning and will yield the same results. Both X plus Y or np.x dot add X and Y. And for this one, we are calculating subtraction. And for this one, we will calculate multiplication. But this is not the inner product. This is not the dot. This is not the dot multiplication of the array. For this one, we are just multiplying elements on the same position. For example, the first element the first multiplies by the first, and the second multiplied by second, and these are not dot products. And we have another function for the dot products of the matrices. And here is the division, also division by division of the elements on the same position, not otherwise. Yeah. We can also get the square root of the array. And note that unlike MATLAB, the dot here is a multiplication, not the matrix multiplication. And we instead use the dot function to compute the inner product of the vectors and to multiply a vector by a matrix or to multiply between matrices. So we can do this, computing the dot product of V and W. We can also use the add operator, which is equivalent to NumPy's dot operator, which will also get a value. And here we're computing the product of matrix and vector using the dot function. We can use x with the dot function v, or we can say np dot x and v, and we can also use as x the add operator and v. And these three operations are the same and will yield the same results. And we are here computing a matrix product, and both produce the rank 2 array, and the three expressions will also yield the same results. NumPy also provides many useful functions for performing computations on the arrays, and one of the most useful is sum. And for the sum function, we are summing all the elements in this array, and we can see on the next line. Yes, here. For the first line of code, we're computing the sum of all the elements of X. And for the second line of code, we're only computing the sum of each column. Axis equals 0, meaning each column, and axis equals 1, meaning each row. So this is a very useful function to compute the sum of the whole array, or only the column, or only the rows. There's also a full list of mathematical functions provided by NumPy in this link, and you can look into the documentation and play with the codes. Apart from some mathematical functions, we can also do the transpose of a matrix, which is x.t. And here we are seeing the transpose of the matrix, just altering all the columns into the rows and all the rows into the columns, and that means that's the transpose of a matrix. And here Yeah, this is a 1 by 3, and here we get a 3 by 1. This is the transpose of a vector. And there's also another very useful feature of NumPy, which is called broadcasting. That may be a little bit difficult to understand by reading the text, but after I show you the code, that will be really straightforward. It's really powerful and saves a lot of time, and is a special feature of NumPy. For example, if we are creating a matrix called X, and the matrix is here, and we want to add a vector V to each of the rows of the matrix X. So if we do not know about the broadcasting, and we can just create a for loop, like for every row of the matrix X, we will multiply that. We will multiply the vector V to that row. So here, the thing work, but the thing is that for loop is very time consuming. If you have millions of rows of data, and that will cost you a lot of time, much more time than this one. So the broadcasting function just automatically allows that to happen. So if you add V to X, then that will automatically yield Y. Although you are not adding that to each and every line of the matrix, that will automatically compute that for you. So for this one, you can see the broadcasting of NumPy. And these are also two of the potential methods, and I will not further illustrate on that. We will just see how the broadcasting works. And for this one, this is the same matrix X, and this is the same vector V. And if we are operating this line of code, Y equals X plus V, and we can see that the NumPy just automatically add V to each row of X using broadcasting. And when we print Y, and V is added to each and every row of the matrix X. So the text below are some of the features and explanations of the broadcasting. We do not have enough time to cover that, so maybe you can look at have a look at the documentations and explanations of that broadcasting function and that broadcasting feature, and that might be very useful. Maybe we can have a little break of 5 minutes, then we will continue to pandas and matplotlib. All right, everyone. I think we can move on to Pandas. As for Pandas, is a very useful tool for data analysis. It's a great tool for handling and analyzing input data. And because many of the machine learning frameworks enables Pandas input, so it is very important that you get to know the data structure of Pandas and get a comprehensive view of some of the data functions, basic functionalities of Pandas. So this is a basic introduction to pandas today. And the core concepts are some of the data frame in pandas, series in pandas, and also I will cover some of the basic functionalities and data analysis procedures. So the primary data structures in pandas are implemented as two classes. The first is data frame, which you can imagine as a relational database and with rows and columns with names. If you are familiar with Excel or some data in CSV formats, that's also quite similar. And as for series, which is a single column in a data frame, and the data frame can contain one or more series and the name for each of the series. So the series is just columns, and data frames are rows and columns have names. So that's basically the data structure of pandas. So here, first we import the package pandas SPD. And here we can create a simple data frame. And when we created a data frame, we can use the syntax pd.dataframe. And inside the bracket, you can see you can assign a name of the column and also a value of the column. That can be one value or a series of value. And we can assign the names, like name to column 2, and also the second value of the column 2, and the name of the column 3, and also the values of column 3. And note that the length of the value 1, value 2, and value 3 should be the same so that we can create a data frame. Or you will get an error because the values are not of the same length. So in this time, we have a data frame called df. We assign this data frame to df. And as we can see that the name of the first column is called name, and the values are represented as lists. So you can see that this is a dictionary here, and with the key name and the value as a list. So here, the key is the column name, and the value here are the values of this column. So after we run this code, we can see a data frame is created by pandas, and there are a total of 3 columns called name, age, and pet. And as for the series of each column, and these are the data that we inputted in order. And if we want to get to a specific column of the data frame, we can put that column name inside this bracket. And when we print df with df name, we get the specific column called name. And when we want to know about the type of each column, and we can get this a PD series. And each series means each column, and the type of each column is a PD series. We can also view the column names and the index values of a data frame. And if we operate these line of code, which is df.columns, we will get all the column names here. And if we type df.index, and here we will get that the index of df starts from 0, stops to 3 with the step 1. And for this, we can this information means that we have 3 rows in this data frame because the index is from 0 to 3. So for this, we can see the names of the columns and also how many rows are there, how many columns are there in the data frame. We can also use shape, which is quite more straightforward. We see if we type in df.shape, we will get the rows and the row and the column number. We can select the column by name in 2 different ways. One of the ways is to print df with the bracket name that I have executed on before. And the other method is df.name, and these 2 will yield the same results. These are the same, so you can choose either of them. Sorry, it's a little bit slow. We can also select multiple columns of a data frame. by including these columns inside a list. So here, if we want to get both the name column and the pet column of DF, we can put the strings of the related columns inside a list, and this list is inside another bracket. And by this type of code, we can get two columns, the columns that we're asking for, the two columns of the data frame. We can also select a row by index by using the iloc function. We can always access any row in a data frame using the iloc following by an integer I. And the result is a series object for which we can access values by using the column indexing. And here, if we are locking, if we're like using iloc and the index is 0, we here get the first column of the data frame with the name, age, and pet. And the first column you can see here is Bob. The first column is Bob. Sorry about that. The first row. I was mistaken about that. Sorry, the 0 means the first row of the column. And there are also some useful functions that we can operate on the pandas data frame. And one of the very useful function is the sort function. If you have a database and you want to see, you want to sort one of the rows, or you want to see the max and minimum values of a row or some stuff like that, we can use the sort function. And there are two ways to sort the data, that is by index and by value. And I incorporated some examples here. When we sort the data by value, we mean sorting according to a value in a column. And in this example, we sort the rows of the data frame based on the values pet column. We can see that pet column is not represented by data, by numbers, and it insists that there are many words inside that. So when we are sorting by value, we are sorting them in alphabetical order. And if we send the ascending feature to true, and meaning that's from A to Z, and when we get the descending order by setting the ascending to false, we're getting from Z to A. So, and in place is another very important feature that we should always remember, because if we set in place to true, and the sorted data frame will like cover the original data frame, meaning that we are not creating a copy. Instead, we are alternating the original data frame. And if we set in place to the default false, meaning that we are creating another copy of the data frame, which is sorted. So if the safer version will be to setting in place to false, so that we will not alternate the original data frame, and we are creating another copy of the data frame, which is a sorted version. So for this line of code, we are sorting the data frame according to the value pet, which is the column called pet, and we're setting in place to true so that the results we get will cover the original results, and the DF will be alternated with the sorted version. And we set ascending to true, meaning that we will sort that from A to Z. So we can have a look at the data frame now. It is already sorted by the pet column, and here is in alphabetical order by bird, cat, and dog. And there's also a difference between log and iloc. For example, we are using iloc on the previous section, and iloc meaning that the relative position based indexing. For this one, you can see that the after sorting, the index of the data frame is already not in the order, because we are sorting that according to this column called pet, and the index are not changing at the same time. So when we use df.log 0, we are retrieving the actual index 0 row, which is the row Bob. But if we use iloc here, we will retrieve the relative position based index, which is 0. And for this, the relatively based first row is Tim. So in this, so this time we will get Tim. This is a little bit different here. We can also use ilog to select all the rows of a column. And we can also, here is all the rows of the first column, sorry, on the third column. And we can also use ilog to select the last row. So the part before the comma just represents the row, and the part on the right of the comma represents the columns. So for this time, we are this means that we are selecting all the rows, and this meaning that we are selecting the column with index 2. And for this expression, we are selecting all the columns. And for this expression, we are selecting the last row. So this is in the order of the row and column, and row is on the left to the comma, and column is on the right to the comma. Yeah, so here are some basic pandas concept exercises. Maybe we can start all over again from the gentleman on the first row. How can we create a data frame with the data above? Yes, pd.data frame. What braces? No, we should have first a parentheses and brace. Yeah. So the first column will be yes, and what will be the values? Like this one?
Yes.
But we have already assigned these values to sales, right? All right. So this is just sales. And right. And also for cities. So here we will get a data frame like this. And we should also assign that data frame to a variable so that we can store that data frame inside DF. Sorry for that. All right, so by typing DF, we can just get a view of what is inside DF. And later on over here, what is the name of the first column, and how can we see the name of the first column if we haven't got the data frame at hand? What is the code? We can use ilog. It's the column. So the part on the left of the column means rows. So we are selecting like all of the rows, right? On the first column. Yeah, we're only selecting the column, but not the rows. So if we want to get the first column, we're getting all of the rows of the first column. Yes. So this will be like this, and and the first column will be 0. It's like this. So we can get we can get the first column, and the name will be the sales, and there will be 5 rows in the first column. Yeah. The next lady over there, can we sort the data frame by city in descending order? Oh, maybe we can just switch to the right on the right. Do anyone know how to sort that data frame according to the descending order? We can use sort, please. Yeah. And what will be inside the parentheses? We will not set the in place to true because that will alternate the original data frame. Maybe we just set the default to false and not including the in place feature in there. That's right. So, and here we're getting a data frame, a sorted data frame, and sorted that by city in a descending order from S to B. All right, so the gentleman on the second row, which customer is in the last row of the data frame? How can we get the so we're getting the last the data frame is here. So we're getting the last value of the row customer account. How to do that? Sorry, that's a little bit difficult because I didn't cover that. If we want to get the if we want to get the specific column, we can use df customer account. And if we want to, and here we can get like a series of data, but if we have a lot of data, we may not be able to see the last one. So we're using tail to get the last one. So here we can just get the last column. Yes. Sorry, the last row. I'm always confusing columns and rows here. Reorder the columns with customer in the first column, meaning that we're not ordering the rows of the column, but instead we are ordering the columns. For example, here we are like putting customer account in front of sales, and that will be customer account, sales, and city. And to do that, I didn't cover that. You can also Google and check the documentation, but here's the method. First, we can turn the columns into a list. df.columns just yielded all of the columns here, and we get the values of those columns. And here we, if we have a look at the list that we created here, and here we can see this is a list of all of the columns. And here we can assign that. We can just manually change the list with a different order. For example, here we're here we do there might be an easier way, but this works. So in this time we can see that the customer account is switched to the first column of the data frame, and followed by sales and city. All right. This is for the exercise, and below are some of the basics pandas functionality. And most of the time we will not create data by hand. Instead, we import data from large databases or from other formats like CSV or Pickle or just some from other databases. So how can we import these data? So we use if that data is in the form of CSV, we can use p.readcsv to directly convert that file into a data frame. That's very straightforward and simple. And this time I just chose an online database. And if we run that code, and we can see that this is automatically converted into a data frame here. And if we put California housing df.describe, we can see some basic statistics of every column in the database. For example, we can see that there are the count here means that there are 17,000 rows in the database, and also the mean, the standard deviation, and many other statistics about the data. So if we use df.describe, we will get a statistical description of all the data in each column. And here we can get a brief view about what these columns are all about. And if we want to get an example, a sample of the data frame, we can use df.head. And this time it will yield the first 5 rows of the database of the data frame. So here we can see the first 5 rows of the California housing data frame. And these are the specific values of the 5 rows. So by inspecting that, you will get a brief view about what the data look like. And if you want to get more rows, that is default to set to 5. So if you get 10, if it switches to 10, that will yield the top 10 rows of the data frame. However, if you do not use head and you just simply type here, and you will get something like this, and it will shows you the row and the column numbers of that data frame. So both these methods work. So you can just choose whatever you like. There's another powerful feature of the pandas is to graph some of the data using plots and charts. And for this one, we're plotting a histogram of the housing median age, meaning the median age of the house. So if we are running this code, it can just get a histogram of the specific column. We may also apply some of the Python's basic arithmetic operations to each column. For example, if we are dividing the population by thousands, we can just simply input California housing data frame population divided by 1,000, and here we will get another series of numbers, which means that the population divided by 1,000. This time I think is the million, because it's already in thousands. And we can also use the NumPy that I have mentioned before as a toolkit for scientific computing, and the Panda series can be used as the arguments in most of the NumPy functions. For example, if we want to get a log of the population or the area, we can use NumPy dot. It is not catching up, sorry. Yeah, we can use numpy.log on the population, and here we can get the log value of the population. This is a very useful tool to using log for many operations like visualization and other stuffs, which will yield a better results than not logging the values. I think my computer died. Okay. There are also more complex single column transformations, and we can use the function called apply, meaning that we are applying a function to each of the rows within one column. And this is very useful because if you want to add more advanced functions, and that will take a lot of time if you use for example, a for loop. So if you are using that function apply, just like the mapping function in Python, it just can apply the function to each value of a column. And below is we create a new series called population, and we're creating a new series that indicates whether the population is over 1 million. So we just use the apply function here, and lambda. This is an argument in the function, and this is the variable for every row. For example, we can change that to x. Is okay, and also value is okay. So it doesn't matter what the variable you're putting here, but this is the this is an argument of that value. So for every value, this line of code means that for every value in the population column, we will check if that value is over 1,000. If it's over 1,000, that will return a true, and if that's not over 1,000, that will return a false. So meaning that we will apply this function to each one of the rows of the data of the column of the data frame. So after we do that, we will get a value for each of the row. For the first row, is true, and there are other rows that are false. So this just saves a lot of time than just manually conducting loops. And we can also modify the data frames. And this time we are adding 2 series to an existing data frame. And we're not using the California housing data frame now, and we are using the city names data frame. And here we create a data frame with the city name and the population, and there are only 3 rows in the city frame. And now we're adding new columns in the city data frame. And first we are adding a series called area square miles, and we're adding another column called population density, and this is calculated by the number of population divided by the area square miles. So after operating this, we can get 2 brand new columns to this existing data frame, and the first column is area square miles and the second column is population density. So this data frame now has 4 columns. Now come to the exercise. So using this data frame first, the first question is, this is a little bit difficult one. We want to know whether the city is named after a saint and whether the city has an area of greater than 50 square miles. So we are using 2 conditions. The first condition is named after a saint, and for this one, there's a hint that the San in Spanish means saint. So if the city starts with SAN, then that will be named after a saint. And I will choose one of the persons to answer this question. Maybe the girl next to the gentleman on the second row. Can you do you have any idea of how to filter this, how to apply that to this data frame? All right. Maybe we will just speed up. We can have a look at the solution right here. There's a solution box on the below. And here we can see that we are creating a new column called is wide and has same name. And if the 2 conditions are both met, and the first condition is the column called area square miles is over 50 square miles, and the other condition is the city name starts with San, SAN here. And if both of these conditions are met, that will be a true, or if not, if one or none of these are met, and that will be a false. So when we operate these code, then there will be a 5th column called is wide and has same names, and that will be the true or false Boolean values on respective rows. And here are also some of the basic operations to the city names data frame. We can see that index, and we can also reorder the data frame by index, so that we are reordering the rows of the data frame. And this is our order, and when we apply that order to the data frame, that data frame will be sorted according to the order that we assigned. All right, and there is another little exercise here. Maybe we can just go on. For this exercise, Yes, and for this exercise, we're trying with re-indexing the data frame with values that are not in the data frame. For example, there is only the index 0, 1, 2 in this data frame, but if we want to access to 4 or 5, and what will happen? And the thing is that that will not return an error. Instead, that will create a row with all non-values in that data frame, and that will be really useful for our later data processing. Kathy, could you please set me to the as a host so that I can share my screen? All right. All right, we can continue then. Yeah. So as for if we are re-indexing the data frame with the index that we have that is not previously existing in the data frame before, it will yield NaN values for each of the index that is not previously in the data frame. And that's all for pandas. So we have a little time of 10 minutes. We will quickly go over the data visualization section using the matplotlib. And first, this is a plotting library, and in this section, I will give a brief introduction to the pyplot module. So here we are plotting the pyplot module of the matplotlib SPLT, and running the code right here. And here we are plotting. Here's a brief example. We are computing the X and Y coordinates for the points on a sine curve. And for this one, we're plotting a sine curve, and the range of X is 0 to 3 pi, and that with the increments of 0.1, and Y is the sine, the relative value of respective value of sine X. And when we plot, we will get a sine curve. And we can just add a little bit of extra work, so we can plot both sine and cosine on one plot. So through this code, we can see that both the sine and cosine is on the same plot. And we can also add some subplots for different things in the same figure using the subplot function. And here's an example. If we want to plot like two plots in the, if we want to have two plots in a subplot, we can operate this code. And here we can see that we are creating a subplot. We're creating a subplot grid that has the height 2 and width 1, and set the first subplot to active. And when we set the first subplot to active, we can make the first subplot using the X and Y that we have assigned before. And then we set the second subplot to active, and here we can just plot the cosine curve. And after executing these code, we can get one plot with two subplots. And also we can plot the data from the data frame that we have created before. And here it is, we have come back to the California housing data frame. And if we want to plot a box plot of all of the variables inside it, all of the variables, meaning all of the columns inside that data frame, we can use California housing df.plot. We choose the kind of the plot to the box plot, and we can have many subplots here, and we have the figure size over here. And after we adjust the spaces before the two subplots, we can get a very beautiful plot over here. And this is the box plot of all of the variables contained inside the data frame. So this is the longitude, latitude, also the median age, total rooms, total bedrooms, and all of these data are plotted in a single plot. And for this, you can see that you can see the distribution and the maximum, minimum, and the outliers of each of the columns of the data frame. And for a single preparation for the next machine learning one, if you want to plot some linear regression, if you want to see whether there are any relationships between the two of the variables, you can first make a scatter plot to see whether that relationship is positive or negative. So so from this one, we want to investigate whether there are any relationships between median income and median house value. As we assume is that the higher the median income, maybe the higher the house value, because the more income we make, the more expensive our houses will be. So when we plot that into a scatter plot, we can see that here that's basically a positive relationship. The higher the median income, and the higher the median house value. And in the next class, we will cover some of the supervised and unsupervised machine learning methods to investigate these kind of relationships. So we may start with regression, and this plot may be a good preparation for some of the linear regression and other regression analysis. So that's basically so much about it today, and there are no homework for today. So maybe you can just look through the documentations and try out with the codes and play with the codes and see whether you have grasped some basic concepts of Python, NumPy, Pandas, and data visualization techniques. So this is the end of today's workshop, and have a good weekend, everyone. Thank you.